Right, short presentation. Training day 2 already. And yeah, the agenda of today is to define an assembly, make use of drawing units, and to make plate parts. So the first two, defining an assembly and drawing units, are very related to each other. And oh, by the way, I don't know which screen is being recorded of this team viewer session. It doesn't matter really. Okay, so the first two are very related, and then the third one is making plate parts. And there, yeah, you make actual construction elements. So defining an assembly, and then finally we're going to make the plate parts. And what are plate parts? Well, that is something like this. So here you see a web frame of a midship section of, I don't know, container ship or something. And then you see here on the right top, you see it highlighted, or one of the plates highlighted, and also marking lines on it. Yeah, it's in fact a plate part is also a MasterShip part. And a MasterShip part is, in fact, a block reference. And I don't know, do you know what a block reference is?
I have no idea. Block reference. Is it just like a normal block?
Yes, indeed. So it's yeah, it's like a group.
Okay. Yeah.
So I think in Rhino you use groups.
Yeah. It's Rhino is
Yeah.
group.
Yes. So it's similar to groups. So it are just lines in a group, so to say, and then with data in it. And this is data like the thickness of the plate and the ID of the plate, things like that.
Okay.
And that data is also saved in the project database of MasterShip. And then you also have solids as a representation. So these solids are just there. They do not have a real function other than a representation. So the solids do not contain data. It's a block reference with lines that contain the data. And then finally we have TOM, and that stands for template oriented modeling. And yeah, that enables you to model quicker than when you draw everything by hand.
Yeah. This one is for example, can you give some example on Tom? This one, for example,
Yes.
example of Tom.
Yes. So, for example, a bracket maybe.
Bracket.
Yes, and that's in a library. And then if you want to make this bracket, then you give a few parameters, you fill them in, and then the bracket is drawn automatically. But you can also do it for maybe a web frame or for a floor or anything really. You can also do it for cutouts. So here you see those holes. Yeah, they are also made with Tom. And here you see a few stiffeners. I don't know if you see them very well.
Yeah.
Those stiffeners are also made with Tom. And yeah, you will see it. You will see how it looks. Yeah. Okay. So I think let's get started. I'm going to share my screen. Okay, so if you have the assembly, then you can, you probably already seen it, but then you can select a drawing and open it. And then if you select an entity, so I select here the top line, so the deck. Then you see here in the properties, you have a extra tab here called MasterShip. And then you see here an entity tag. and it says ship service main port side. And that means that this belongs to the main database. If I select this one, for example, then I see ship service tank top port side. And if I select one stiffener here, it was a bit too much. So if I select one entity of the stiffener, then you will see entity tag ship service side PS9. And that refers to that MSD. So if you look here, then you see we have null shape, girders, stiffeners, and decks. So if I go to, well, let's do stiffener in this case. And this one had the tag, what was it? Ship, service, side. So side. And if I then look at side, so then you know that's the same. So then you can retrieve the information. So all of this, oh, that's not needed to have that there. But all of this information is from the MSD. So if you look in the model in the assembly that we just made, you can open it. So the training, the previous one. Then you can also select entities, and then you can see where it came from.
Okay. Let's say what frame? We choose one frame, right? Frame.
Yeah. It doesn't matter which one.
Doesn't matter. Okay. So double click the frame.
Yeah.
Open reference. Okay. Oh, okay. So, all right. Properties manager. How do we show that one? Yeah. How do you show the what is that? Properties.
You mean this window?
Yeah.
Control plus 1.
Control plus 1. Control plus 1. Oh, okay. That is properties.
Yeah.
Okay.
So then you select one, and then you see where it comes from. So then you know this was a surface, and it's in the
tank top. Yeah, surface. Main tag boat. All right, and then we have a shape. Then we have side stiffener. Okay.
Yeah, sometimes that's useful to retrieve that information. All right. So that's that. And we can start making parts now. So okay, we have a difference. We have two types of parts. One is called non-dynamic parts, just regular parts, and we have something that is called dynamic part. So we start with the simple one. So what you can do here in this frame, so I don't know which frame you have, but that also doesn't matter. You can draw a polyline, for example, and then you can just draw any shape you like, so something like this. And then you can do, those are just normal AutoCAD polylines. And then you can do bounded panel here at the top. And then if you select all your entities, then a part is created. And what you see here is that it gets an identification. And that's assigned to the part, and it's also saved in the database. And you can find this back in reports, or maybe make a bill of materials. Use this for the bill of material. Then you can assign it a material, steel, wood, I don't know what. And you can assign it thickness. So I'm going to make this a very thick part and do 25. And you can also assign it a operation. So maybe you say this needs to be flanged.
Okay.
And then you can click OK. So, and what you see here is what I told you in the first day. I told about the polyline technology. I don't know if you still remember that.
Yeah.
Yes. So that polyline technology makes makes a fair shape of it.
Yeah, smooth
So
surface.
yes. So sometimes that's a problem.
Yeah.
But if you now do, for example, this with lines, let me do it like this, lines. Then it should be good.
Ah, okay.
Yeah.
So, all right. Okay, that's the trick. Okay.
Yes. So that's good to remember. Do I want to make
polyline and line?
Yes. So this is polylines.
Okay.
And this is normal lines. So that's good to know. And sometimes this is better, and sometimes this is better.
Yeah.
But so then you are aware of it now, so that you really see that difference. I'm going to delete this. And so we're going to look at this. So we made a part of 25 millimeters thick. And if I select this, then you see that what becomes highlighted. So, and what is highlighted is only the line, so the block that I spoke about earlier. And you also see the solid itself.
Yeah.
So this is the plate. So, and this is the solid. And as I said, the solid is just a representation. It does not contain any data. So you can also delete the solid, and now the part still exists.
Okay. Just normal delete the solid.
Yeah, you can do it. I mean, there's no reason to delete it, but to make the point, all the data, so all the interesting information is saved in this block reference, so in this group of lines. And this solid is just here to check whether the direction of the plate is right. If you do not have any collisions at all.
Okay.
And you can also click this solid, and then there's also a bit of information on it. So you see here the model ID and where it came from.
So this model ID can I mean, if we can we, how to say, define ourselves or it automatically defined?
Yes, we can. So if we do okay, so let's make a new part.
Make a new part. All right.
And I'm going to make one here. So I do again bounded panel. I select lines. And what you see here is the AF30J. So the A stands for the hull. So we know this is a part that is in the hull. And then we have the F. And the F stands for frame. And then we have
A stands for what?
The A stands for hull. So this is a hull structure. Yeah.
Okay.
Yeah.
All right.
But you can also find this back in the manual. So you do not have to remember it. You can find it back in the manual. So, and then frame 30, and then we have J, and J stands for the, that it's the So this increases. So this is now J,
Yeah,
and the next
yeah,
part that we make
yeah.
is M or
Yeah,
K, and then the
right.
next part is L, etc.
Just two different between part.
Yes, 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 exactly. So, but you can also change it yourself. So if you say, no, I want this to be, yeah, what can it be? Maybe you like to do it like this, frame, and then part 2, then you can also do that.
Okay.
So you can make your own codes as well.
All right.
Yeah.
Okay, so okay, let's say if we do next, will it follow the first? I mean the first this one.
So if it's so
Or
then if it will be L, you mean?
okay, okay.
You mean okay? Let's try it.
Okay,
Let's
so
try it.
let's try a new one. Okay.
So we do this. Make the bounded panel, and then apparently
I see, I see, I see. So it
so
start from the first that we define. Okay.
yeah. So then you can proceed to do 3.
Okay.
Yeah. So, but that's up to you. So this code is automatically generated, but you can also define it yourself. But it's up to the engineer to decide.
Yeah.
So that's that. Maybe we can make something a bit more realistic. I'm going to delete this. And maybe we can make a nice floor here. Floor. And here also one at the side.
Okay.
So you can follow along if you like.
All right, all right. I mean, let me see first, then then I can try.
Yeah.
Yeah.
Okay, it's good. So what I do is I'm going to draw a line somewhere here. Or maybe it's good to do it from the. Let's do it in the center. I do it at minus 100, 0. Oh, it was a mistake, by the way, line. So 0 minus 300. So this is now my 0 point. And I move this to say, I don't know, 75, like that. Or maybe we can also do it exact. So then it's minus 7500. Oh, that was the wrong direction. Anyway, we can also do it here. No problem. So this is now at 75,000 here.
Okay.
You know what? No, let's do it properly. Let's do it properly. Move it. Select. Okay. Move it there. 7500. Yeah, good. So this is now at 7500. And maybe I also want to make one line here. It's maybe nice. So I make another line when I start this at minus 10,000.0. I'll make it this long. Enter. I move this from here to let's do 3500. And I'm going to copy this with maybe 16. So now I have made a little space in between since there will be a longitudinal girder going through or stringer through.
Stringer, yeah.
Yeah. So we can do that here as well. So we have here the tank top. So then we should make one line at what was it? minus 10,000, and at 1,012 maybe. Enter. So we also have a bit of space here for the tank top plate.
All right. So instead of I mean key in all these what the point, can we just offset let's say like say what we call this one side shell or tank top?
Yes, we can do that. We can do that. I will show that to you in a bit.
Okay.
Yeah. Very good. Okay. So we can make a bounded panel again here. So we select the entities. First the upper, like so. So now we have one plate here. This is a bit too thick. Maybe make this 12. And may increase by 1, so 4. And I'm also going to make one here. Like so. And make it also 12, that's fine. Okay, so we have now 2 plates.
Okay.
And that's just the standard. And we can also do it with Tom. So with the templates. So this is user defined. This is just any shape that you like. But you can also do this. Create parametric part. And then if you click this, then you do make. And then you will get then you can choose, okay, what do you want to make? A bracket, a floor, or a web frame?
Okay.
In this case, I go for an easy bracket. Maybe this one is the most simple. So then I can specify my parameters here. And I choose a bracket, since a bracket is something that you will use very often. And also repetitive. So I can say maybe I want a base length of 400, and we can also give it a small offset, so that to account for a plate thickness maybe. So I can do 12, so that's this here. Give it a snipe of I don't know, 50 reference length, make it 600 high, also a small offset. Then it's also 50, no radius, and 25 millimeter radius for welding, and no fillets. So I've now defined this set of parameters, and I can now save this set. So I can say, okay, this is a standard bracket or standard or standard web frame bracket. I don't know, something. Yeah. So I do okay. And then I can press OK. Then it asks me to select that baseline. I click this. And the reference line. This. And then the side. And then you see that it's drawn here.
Yeah.
Then we again assign it to the ID, the thickness, to make this 8. We don't want this to be flanged. 0. Nothing, just empty. And then we do OK. So now it's created. And you see that here is the small offset for the tank top plate, and here is the offset for another plate. So you will probably use this a lot. So I'm going to do it again. I open the main, go to the brackets, bracket 4. You see that those parameters are saved, so
Okay.
it's easy to make it again. But I will delete it all for now. No, that was stupid. No, what I do, okay, so we just saved that set of parameters here. But I can also load a set. So this is the one that we just defined. But I have other settings defined here already, since this is a existing project. So I can also select this one. And then I have different values. So this is an offset of 200, which is a lot. But okay, anyway. So if I now do okay, then I can select, yeah, here maybe this baseline and this reference line. Now you see that this bracket is created. So this can be, yeah, very useful to have that that value saved. So if I want to have this bracket, then I can again go back to this, the standard web frame bracket. So that's the one we just defined. And then we have those parameter sets again. So that's quite handy to do. So now I can make one here.
So can I ask something? Okay, sorry
Yeah.
to interrupt. Okay, so here I can see just now that we have only one base offset, right?
Yeah.
We have two or one?
Here.
Okay, let's say if we have two different flat thickness. Okay, let's say the we have tank top is 12, and then we have longi is about 8. So
yeah.
can we define that one?
Of course. So I delete this one. And then I will make that again. So the bracket and the bracket 4. And you can specify it here. So here you have the base. So you have one baseline.
Okay.
And one reference line.
Oh,
Or the
one
other
is
way around.
side.
You can
Okay.
also say this is the baseline and this is the reference line. You can also say that.
Oh, okay. So now I see a reference offset and base offset. Okay.
Exactly. So we can do this one at maybe 60, which is a lot, of course, and this one at 10. But then you will see the difference. So now I do OK. And then I select this as my baseline.
Base. Okay, select base.
And this is my reference line. And I make it there. So then you see this offset is now 60. Should be. So this is 60. And then this offset is 12.
All right.
Yeah.
Okay.
All right. So that's
okay.
how.
One more thing. Okay. Sorry.
Yeah.
So I see the part name, right?
Yeah.
Okay, we call part name. Okay. Do we need to I mean put it as port and the other one is a starboard or how?
No, you don't have to do that. But that might be convenient. It depends. So yeah, it's up to the engineer.
Oh.
But you can also you can, for example, mirror this one.
If we mirror it, then does it show any port or stuff? Oh, okay.
So now here the S is now appended. So then you know this is starboard.
Okay. The other one is
nothing. So we can do that. So let's do this one. So this is frame 36. So we can do mirror. This is now
6S. Oh, all right.
Yes. So you will use that mirror a lot. But yeah, so if you draw something here, like so. Oh, this is This is nothing. We draw something here. So on the starboard side, then nothing is added.
Okay.
So then you would have to do it yourself. Then you have to do SB. Yeah. But if you mirror it, it goes automatically.
It becomes port.
So yeah, if I now mirror this back, then it should be indeed port. Yeah.
Oh, it's BP.
But then the P is added. Yeah. So that's maybe how you can remember it. If there's nothing appended and there's another one, then yeah.
Okay. Okay.
Right.
All right.
So let's see what's next and nice to show. Yeah, maybe it's nice to. Okay, so we did those floors with just AutoCAD lines. So then you can define any shape that you like. And we did it with a template, so like this, so that then you can quickly model.
Okay.
But we can also do add details. So if I click this, add detail, then it asks me to select a part. That one. And now we again, so this is also Tom, template-oriented modeling. Then it gives me some common details that are very often used. In this case, I can go for extrusions. And yeah, let's pick this one, extrusion 3. And then you have to give some parameters again. Maybe we already have one. Yes, we do. What was this height? I'm not sure. Maybe 150, I don't know. 25 and the cut out width of okay. So I said here the flat bulb will face right. The flat bulb height, so we define it by parameter. 150 meters, we want to have the cutout, 150 millimeters. And then some other parameters, we want to have it 80 millimeters wide. And we want to have this red hole here for the welding. We want to have that 25 and a small top clearance of 15.
Okay.
So we do, so we can save this set. Maybe that's nice to do. So extrusion for long longitudinal stiffeners. And we have saved it. It's not needed, but it's nice to do. We do OK. This is select the contour, which was in that drawing. OK. And then we select the extrusion. So select this one, that one, this one, this extrusion, that extrusion. Now I do enter, and then it asks me to select the side. On which side do you want to have the extrusion? On this side or on this side? Well, I want to have it here. And now we have the cutouts. And we can add more detail. We can select this part again. And we go to the main. And we can maybe...
Yeah, opening.
Sorry?
Yeah. So
yeah. So maybe a hole or maybe a welding hole. That's also nice. We'll use that very often. So we can do 25. That's okay. And then you select this line, that line, there. Now you see you have a small welding hole here. So that's easy. What you also can do, select this part again. The cutouts. Yeah, you have a lot, so you can do this one, cut out 10, then you get 4 welding holes in each corner.
Mm-hmm.
You can make multiple holes. You can make a simple cutout. You can make a hole at a specified point. So there, yeah, just some common tools. So in this case, I can go for a hole. I say I want it 300. I want to have it 600 high. Oh, that's a bit too much. 600. So as you can see here in this image, it asks us to select a midpoint. At this moment, we do not have a midpoint here. So then we just select somewhere.
Okay.
And then it's there. But
okay.
Maybe you want to specify it a bit more, so maybe it's better to do copy at a specified point. So maybe you say I want to have it 500 from there, and copy this line from here to what's the center? I don't know what the center is. 1000 or something. No, it was not. Nah, anyway, so then you can say I want to have this as the exact center. But that's yeah, that's just how you do it. What you want.
Let's say if we want to modify the hole, can we just delete the hole?
Yes, very good question. So we have here add detail.
Okay.
And here we have remove detail.
Okay.
So then we click remove detail. Select this part. Then here you see we have the cutout, the extrusions for the hole. We just delete the hole.
All right.
Yeah. So this is how it looks now. You see also that plate direction is going forward as we specified it. So now I save this drawing. I'm happy with it. Then I go to the assembly.
Okay.
And then you get a small pop-up window here.
Okay. Oh, reload.
Yes. So it says something is modified. And then you can click reload. And then yeah, you see it here, but I change this to shade it with edges. Now you see it here in the assembly. So, and then if you select it, then you can open it again. Now, so you can do this for all the frames. And now it looks, very simple at this moment. But yeah. So that's how to do that. I think I can show you more about creating parts. Yes, and I will. Yeah, okay. So what you can also do, and that's quite nice, is we used just normal AutoCAD lines here. But you can also use reference lines.
Reference line.
Yeah, and the difference between a normal line, a reference line. So this is also a reference line here at the deck. Those light blue lines are also reference lines. The difference is, so this white line is not saved in the project database of MasterShip, and this line is saved in the project database of MasterShip. And I don't know if you have seen in the video that was on YouTube. Then I copy one frame to other frames. I don't know if you've seen that.
Yeah.
So if you want to do that, then you need to have reference lines. So lines like this.
Mm-hmm.
No, not that. Lines like that. You can also copy if you use those lines, but then the shape will not change of the part.
Mm-hmm.
So for here in the midship, this is fine. I mean, since the midship is all the same frame, so that's no problem. But if you are, for example, in the bow, then each frame is slightly different.
Yes.
So then you will need reference lines.
Okay.
So how to do that is here, and it's also easier to model. So it's not only needed to let's leave this, by the way. It's not only needed to make the copy, but it's also just easier sometimes. So what I can do is I can click here at reference line.
Mm-hmm.
And then it asks me, do you want to create a new one or use an existing line? So you can do an existing line, and then this line, for example.
Mm-hmm.
And now it has turned purple.
It turned into reference line.
Yeah, so now it's a reference line. So now it's saved in the database as well.
Okay.
And you can also do create a new one. And yeah, you can choose between offset or 2 points. But yeah, I think 2 points is a bit stupid, since if you use 2 points, then you specify where XY coordinates and then a cross line between that. But yeah, I would say that it's easier to just convert an AutoCAD line to this. But
Yeah.
but you can also do offset, and that's quite nice. So then you can say I want an offset of 7500, and then you can select this entity, for example, so the center line, and then you can select the side, and now it's drawn here. Yeah, I have a bit of trouble since my lines are not highlighted, so that's maybe a bit hard for you to see, isn't it?
No, I still can see it.
Yeah. Okay.
Yeah.
I don't know how to. I don't know why. No. Anyway. Okay. So yeah. So that's an easy way to do it, and you can also use something that is called named parameters. And a named parameter is like a variable which you can define, and then you can use that variable instead of a value, and that's pretty nice. So I'll show you. I don't know. Have you ever used maybe Inventor?
Inventory? No.
Okay. So Inventor is also a product of Autodesk. And with that, you can make a parametric model. And this is a bit similar to that. So what you can do is, if you make another reference line, then do create and offset. And then it asks you specify an offset. And in this case, I want to make an offset of this tank top. So then I can do, for example, tank top thickness. And then say, well, this variable does not exist. And then I can specify it. So my tank top thickness is 12. Okay. And then I can select this entity and make the offset. Okay. So now I have this line here. Fine. And I can make another one. So I can make another offset. Let's first make a normal line here on 10,000.0. Here, so that's then a baseline. So this is now my base. And I'm going to offset this to here, so to specify my offset. I call my offset tween deck. And my tween deck is at 3500 maybe. Select this entity and I change it to there. Okay, and then I make one final one. Also offset, and I call that tween deck thickness. And that's maybe 16 millimeters thick. And I offset it as well. So I have now something similar to this. And the fun here is that I can now change those named parameters. So here are the named parameters that I have. But now I can say, yes, now I can change it. So I can say, edit now, my tween deck is not here, but my tween deck is here. It's 1 meter lower. I say, okay. Then I go back to MasterShip. Here, do the update. Here it says the tween deck is changed. We mark this update. Okay. Continue. Now this takes a bit of time, apparently. So I don't know why exactly, but.
So this is to define the reference line.
Yeah. So yeah, you see what happens now. The tween deck is now shifted 1000 millimeters lower, and if everything goes right, then the upper line will also lower its position.
Okay.
So this named parameters can be useful if you do not know, or yeah, if you do not know the exact dimensions, but you do know, yeah, some sort of the dimensions.
Okay.
So then, yeah. So it's changed now. So then you have yeah, still freedom to move. So yeah, if you do not know the exact dimensions yet, but you know the location for 90% sure, but not 100% sure, then you can use maybe this. Yeah. So that's sometimes nice to do. So now I can make a bounded panel here, like so.
Reference line.
So make this is good. And I can also do here maybe paint. Okay. So I now have this bounded panel. And then if I do add detail, and I select this part. Okay, main. I can also use, so if I want to make a cutout here, I can also specify something here. So for example, R weld hole. Then I do okay. And then I say, okay, I want to have a welding hole of 25 normal. Okay. Let's see. I'm going to make the welding hole here and there. So I have now one small weld hole here. And then I do again add detail. I select this. Yeah, main, that's good. Good. And then, yeah, I can either choose a value like 60, but I can also say again our weld hole. Or you can say named parameters, and then you see which parameters are in my project at this moment. And then you can just simply select our weld hole. And yeah, that's sometimes useful. Then you do not have to remember all the values and all, but just remember where you stored it. I'll leave this for now. So we have this weld hole, and now I'm going to update this value. So I don't want to have weld holes of 25, but I want to have weld holes of 100. And then you can also update.
It's breaking up.
And then the WATL, so it says here, this part will be affected. And now you have a bigger WATL. So that can be useful. So what is the last that you have seen?
Yeah, about the I think about the referral line. Yeah.
Okay.
Yeah, that I think you meant to show that when we copy to another frame and so on.
Yeah. Yeah. Have you also seen this, like the welding one? Named parameters?
Yeah. Yeah.
Okay, good. Okay. So then indeed, so the final step can be to copy a part to another frame. So let's see what would be a nice case. I think something like this can be a nice case. Yeah, let's try that. So I'm going to copy both of those frames to a frame with another shape. And then you will see which one, yeah, how that looks. So I go to, or in this case, it will, yeah, okay, let's do it. Select from the drawing, select this part, and I select that part. And then I'll copy it to frame.
Let's say we copy to the forward.
Yes, exactly. So this is frame 46. And then I do OK. So one side is with reference lines, the other side is without reference lines. And apparently it filled both. It's strange. It might be, what is this? This is shape. All right. So yes, this is okay. So this is okay. Okay, let's do one successful one first. But then that would be in the midship, so that's a bit boring. Then you will not really see a change.
Yeah.
So okay, yes, okay. So we can do it. Okay, let's do it first in the midship. Copy. Select this one. Okay. Then we go to frame. Which one is this? This was
For the
30.
forward. Yep.
34. For okay. Sometimes this goes quick and sometimes this goes a bit slow. I don't know why. Okay, so we can see here this part is successful. It was made with reference lines. And the other part was this one. Was made with the AutoCAD lines. And therefore the copy was not successful of that part. This one was made with reference lines, so then there's no issue.
Okay, so that's the difference between normal, I mean the normal AutoCAD line and the reference line.
Yes, exactly. So we can also see why it did not copy to frame 46. So if we,
Why?
yeah, so if we look at frame 30, and then I select this this line here, this site entity, we see the entity tag is ship, surface,
ship,
starboard 2.
Okay.
Then we go to frame 46. And that is ship service shape SB1. So that tag is, so yeah, so the tag is different. So that's the problem. And if you go at frame 34, and then you see here ship service SB2.
Is that because we already specify our this drawing unit?
No. It's because of this. I will show you. So we go to the assembly. Okay. Go. MasterShip. No shape. And then I will draw the surface. This is stiffness. So this is yeah, the hull shape, and then you see this is a surface.
That is 2, right?
Yes, exactly. And this is oh, a hard time selecting it. Come on. And this is also a surface. So that's the difference. So this is one surface. So this is the SB1. And this is SB2.
Okay.
And we so the surface needs to be continuous. But we have a break here.
It has to be the same.
So
it has to be the same, the surface? And
sorry?
I mean, is the surface has to be the same, then we can do this copy to another player.
Exactly. So as long as the surface remains the same, then it's good. But if it changes, then you have a problem. So
okay.
Also here, like this stops here. So you can only do it, yeah, within the same surfaces. But the shape of the surface can change. That is fine. But it cannot do different. Yes, exactly. So that's good to know. It's good to know. So, but say that this complete model, all those surfaces were joined, then it was just one surface, and then it was fine.
Okay.
Yeah, I think that's that clear or not?
Yeah, I think that's clear.
Okay. Good. So that's why we couldn't copy through frame 46. That one is all the way in the bow, and 34 is in the also in the midship. So that's the same. Yeah, I think that's it for today on parts. And this was about everything for parts. And yeah, for this goes is you really need to do this a few times. You've seen it now, but yeah, you really have to do it. It's not very hard to do. But yeah, you will encounter some problems and how does this work? How does that work? And I also showed you the named parameters and all, but you do not have to use it per se. It's a bit more complicated, a bit for the advanced user, but you can do that as well.
Okay.
Um, so yes, I think this was it for this training, so that we have then done the assembly and we have done the plate parts, the construction elements. And then in the next training, we will look at stiffeners, how to define stiffeners and face plates. And then there is again some individual assignments that you can do. Drag it in here. So day 2, we have done this, finished the shell expansion. So we added the girders and the longitudinals, define the assembly, define the drawing units, open the assembly, adjust the assembly and non-orthogonal intersections. It make a part data, and we used the TOM, mirror, reference lines, copying, and yeah, we did not show the project database, but yeah, I can show you that in the next training if you like.
Yeah.
We adjusted the assembly. But, so yeah, for the individual assignments, I have 2 assignments here. One is for the assembly manager, so how to define an assembly. I think it's pretty clear to you how it works. So you have to decide for yourself whether you want to do it or not.
Okay.
This one is nice to do, the parametric parts. And I would say, yeah, look at the manual to do it.
Yes.
But try it on your own tug model. Yeah, I think that's best.
All right.
Yeah. Any questions so far?
Yeah. I think let me do the exercise first, and then when I enter something, then yeah, then maybe the next meeting, next training, we can I mean, I can ask the question.
Yeah, exactly.
Yeah.
And yeah, it's really, you have to play around a bit, try out, see what happens.
Yeah,
that's really. So this is in fact also not a very big exercise, small exercise, and then yeah, you just have to try it, see what
Okay.
happens.
All right.
Okay. Can you show me that one with that floor?
You mean okay? This one?
Yeah.
It looks something okay, because here I can see 1, 2, 3 more what do we call it? What, entity?
Entities. Yeah.
Entities, yeah, sorry. So in the part, it's only up to 3 or 4 entities. So that's why I cannot select. Yeah, right.
Yes. Okay. So yes, in that case, then you have to make it yourself.
That then we have to generate ourselves.
Yes.
Yeah. All right. That's good.
So
By
then
using parametric or what?
it's here frame 11, right? Yeah.
Yeah. Let's say it's
You
frame
want
11.
this floor or this floor?
Yes, it's okay. It's up to you. You can, I think you can make it the bigger one.
Okay. Good.
Yes.
So what I will do is add detail. Yeah. You also tried this probably. And then
Yeah.
you go to cutouts, but you say there is no. Yeah. Yeah, maybe this one, maybe.
Yes.
But okay.
This one only have 3 entities.
Oh shit, I did. Okay, sorry. Let's go again. Okay. So 1, 2, and 3 is then the side of the ship. Okay.
So 1,
Yeah.
2.
This is what you did as well, right?
Yeah.
Uh, ah. Okay. I'm going to delete this line for a second. I will place it back, but
Okay, it's okay.
let's try it again. Oh, by the way, you can also go here directly. So what you also can do is if you do add detail, and if you use that detail very often, then you can also type here, cut out 3,
Oh,
and
it's
then you go
fancy.
directly to it. So sometimes,
Okay.
if you use it very often, then sometimes that's helpful.
All right. Yeah. Yeah.
So select 1,
2
2.
and 3. How to select 3?
Now it's just enable to add detail.
Right.
I think polyline back again? No. Yeah. Okay, let's try something more simple.
Mm-hmm.
Okay. Oh my God, good morning. Line. And then maybe a spline.
Fine. Mm-hmm.
So we first make a panel of it.
Mm-hmm. Okay. Right. 2 and 3. Yeah. Yeah. Huh.
Yeah. So that works.
Yeah, it's work.
I think I think that's because you have 1, 2, 3
2.
entities here.
Yeah. Okay.
Okay. Wait. So 1,
So yeah,
5.
1. This one is a 1. Yeah.
I'm going to delete this one for a second.
1, 2. Yeah. I have so
Yeah,
many. Okay.
I think that's the case. I think that's the case. So 1, 2, 3
Yeah.
elements, and if it was
Mm.
one element, then I think it would be not would be
Okay.
would be a problem.
So if this is the case, normally we do it. How do we do
Yes.
it?
So how we okay, yeah, good question. So how do
Yeah.
you do it? And to delete this one. So what you do then is you can do 2 things. What I will do, there are always multiple ways of doing it.
Mm-hmm, mm-hmm.
In this case, I would go for reference line
Mm-hmm.
and then do create and then offset
Okay.
and then just for 50, I think. And then select this,
Mm-hmm. All right.
and then
Yeah, you can delete the stiffener first. It's okay.
Yeah. Okay. And then that entity. And then here you have, I suppose, normal entities.
Hmm?
Let's delete this.
Yeah, suppose there's a line.
Where is it?
I don't know.
Maybe it was deleted. I don't know.
Yeah. It's okay. You can just make a line.
Yeah.
So do we need to make the line as a reference line as well?
No, not per se.
Already.
Not per se, but you know, I used this reference line.
Mm-hmm.
So you can also use AutoCAD offset, maybe.
Mm-hmm.
So this is just an AutoCAD tool. And then you can
Okay.
also do you can do the same.
Cannot. I already tried.
Yeah, exactly. So this is on the locked
Right?
layer. This is locked. So,
Yeah.
so therefore I use this.
Okay.
But it's you can also say I
Unlock
unlock
it.
it
Mm-hmm.
and then make the offset as well. So that's also possible.
Uh-huh.
And then
All
you
right.
can do it with AutoCAD. Yeah. But yeah, that doesn't matter really. Okay. Oh, that was not. Okay. And then what I will do is, what's this?
So, no, that's
Uh,
the line I make it before. Yeah, just to do the stiffener.
okay. Okay. We can leave it there, I
Delete it. Yeah.
suppose. And then I will do like this. Uh, So and then I will use normal AutoCAD offset. What is this? It was 150.
Yeah.
Uh, and also this one.
Yeah.
Uh, uh,
Doesn't matter. Yeah.
okay. So then good. And then maybe trim this. No. Trim this. And then can we trim this? No, we cannot. That was stupid. That was stupid. Okay, so this then should be a normal line.
Mm-hmm.
I think you get the point.
Yeah.
Yeah. So what I can do for now to solve this, I can do. You know what? I'm just going to draw something similar, so not exactly the same.
Mm-hmm.
Let's say, okay, good. So I can delete those. No.
Mm-hmm.
And then they are gone.
Mm-hmm.
And then I will just do bounded panel
Okay.
and then select all the entities. Like so.
Mm. And then select the inside.
Yeah.
Okay.
We get gaps.
Oh, that means we have gap, right?
Yeah, exactly. Maybe not 100% sure. Let's go back. Or no, not back. Yeah. Maybe we can also do this. Okay. Then add hole.
Add generic hole. Okay.
Yeah. This part. Oh, hey, this is file data source. This is something that you can use file data source that refers to IDC. Okay, I'll leave this for now. So now we have the whole. So this solid is maybe not drawn correctly. Let's do it again. Yeah.
Okay.
So that's how to do it. So yeah, I'm sorry, it was a bit early, but you should you should use this at generic hole. So then you can make any shape that you like. So I messed up a bit. I'm sorry. So let's do undo it. Back. What you had was good. This is all bullshit. Oh, I think the layer is off. Part outer. Where did this yellow line go?
I don't.
Okay. Now anyway, okay, I'm going to delete that one. Let's draw it again. But
Nah, at least now I know there is a function for the, I mean, to make a hole. Yeah.
yeah, so then you can do any hole, and then you can just draw any shape here that you like.
Okay.
Yeah.
Yeah, I think that's good. Yeah.
Okay. Nice. Sorry, I was struggling a bit. I was being stupid, but
Yeah,
it happens. So this
it's
is
okay.
add generic hole, and then you can make any shape, and then yeah.
Okay, can I ask something? Okay,
Yeah.
stop. All right. Okay, let's say if I mean shipyard, they want the vessel to be break down into block, right? Let's say
Yeah.
we have upper block, and then we have a lower block. So, but that I mean the plate is a one piece. How can we split it?
Yes, exactly. Oh, that's a good one. I will include it split part. Yes, that's possible. Okay, good, nice. So this part is now too big to make, so we can indeed split it. So then you have ship split part.
Ship split part. Okay.
Yeah, and then you can, if you use this command, then you can split it.
All right.
But first you need a few lines. So
Yeah.
me, I
Let's
want
say
you
we split it to how to say, to suit the plate size, right?
exactly.
Yeah.
So you can do maybe Yeah, how long is this?
Or we can just draw draw a plate size and
Yeah, that's
extend the
maybe
plate
good.
size, right?
Yeah. That's very good. In fact, so rectangle or something. Yeah, rectangle. So 6,000 and maybe 2,000. Oh, this is not. Let's say. What is this? This is a bit too big. Let's make this again. Make rectangle. First point. Dimensions. No,
And
6,000.
and
Something like this.
yeah.
That's very good idea. So we move this, and then we can say, well, this fits in a plate. Yeah, you have to find a convenient spot, but
Yeah.
let's rotate it. So yeah, then this maybe.
Yeah.
Yeah.
Oops.
And then you can do ship split.
Split part.
Select the part,
And then
the curve. And I
alright.
don't not 100% sure if this will go right. Yeah.
Yeah, it's
So now we have two parts. And then if you look at it, so this is now frame one and the two is appended.
Mm-hmm.
And here you will see the one is appended.
Is there any gap between these two parts? No.
No gap.
Oh, no gap.
If you want to have a gap, then you really need to draw two separate plates.
All right.
Yeah. So say if you want to split it at maybe a stringer, and you want to have some spacing for the stringer, so maybe 12 millimeters or something, then yeah, you should really draw two separate parts. Yeah, or you can make, of course, another line here, like so.
Okay.
You can also do that, but that will give you a split part. So you can do that as well.
Yeah, then we have the small one. So the small one, we delete it, or?
Yeah, and then you can delete it. But you do have now a problem, or no, you don't. You don't have a problem. But so this is now appended as 1 to 2. So meaning it's split it once, and it's split it twice here. The second split. What I was saying, so you can also do split it twice, like this. This is maybe a bit big.
Yeah, it's okay.
Okay, all right. So then we can do split part. Split part. And okay, so then we split both. But now we have so 1, 2, 3.
3, yeah.
But the
Yeah.
problem is if you delete this now, okay, is no problem. I mean, we fixed it. But it can also be maybe a bit confusing since if you look at the IDs now, you have 1,
And 3.
3. But
Yeah.
yeah, it's not too much of a problem. It's not too much of a problem if it's no, I wouldn't say it's a real problem. It depends. It depends on how you work with.
Or we can edit the block, right?
Yeah, you
So
can do that as well. You can also edit it. So I think you can do it here,
part.
and then you can. No. Yeah, then it says so. I try to rename it to this. And it says, yeah, it's already in use since that's the one that we already deleted. But then it says, well, you can use 2.4 instead.
Or maybe purge it first.
Sorry?
Purge it. PURGE.
Oh yeah. So something like that. You can do that. But what I try now is I save this drawing. And I do now synchronize this drawing. So maybe I can now. Let's try that. And otherwise we go for your solution. So we do frame 7522. Yeah. So now it's fixed. Yeah. So now it's good. Now it's indeed 1 and here 2.
Oh, so we have to update first.
Yeah, so what you have to do, and that's about the project database. We haven't spoken about it yet.
Okay.
But yeah, I will explain it now. That's good. And after that, we go to the stiffeners. So if you make a part, then this part will be saved in the project database. And we can open the project database. So we can go here and then so we can go here to our training. And in this case, it's this folder, and then we can go to data. And here we have the project database. So if we open that, and I think you might have a problem here, but I'm not sure. So you can open this, and then you go to where is it? Normally you don't use it, but I'm going to show you. So then you can go to part definitions. And there you see all the parts that I have so far. So if I'm going to draw a new part now, line or yeah, let's make something like this here. Okay, so now I have this part. And if I update this database, then you might not see it yet. Maybe it's there. Yeah, okay, so this one is there already. It depends on the settings that you have, but okay, now it's here. But if I delete this now, and then I refresh, and it's still here. It doesn't go away.
Okay.
If I do this, so here in the MasterShip ribbon, then you can do synchronize data,
Synchronize data.
or you can do synchronize project folder.
Project folder.
But we go for synchronized data. So with synchronized data, we only synchronize the data in this drawing. And if you do synchronize project, then you synchronize all the folders of your project with the database. I'm going just to synchronize this drawing. So it's done. Now I'm going to refresh this. And maybe I'm looking in the wrong table. That's possible. Yeah, I'm looking in the wrong table, so we can go to part applied. But this is the parts that we actually have. It's not here. So I can do it again. So make a line, enter, part, bounded panel. That's 3. And then we go to the database. This is parts applied. Now it's here. Delete this. Save my drawing. Update it. And now it's still here. And when I now synchronize my drawing, now it's gone.
It's gone.
Yeah. So
Okay.
that's why we were not able to rename that that part.
That part.
So it's good to do this sometimes.
Yeah.
Since if you make a new part, it's automatically added. But if you delete a part, it's not removed.
Remove the.
So it's good to use this sometimes.
Yeah.
What you also can do, and that's maybe nice to have, but that depends on the user and also on how big your drawing is. That if you go to the organizer, then you can go to options, and then you have here.
Synchronize that.
Yes, exactly. So then you can do never synchronize automatically. You can do always or verify synchronization. So say you say never synchronize automatically, then it never does it. If you do verify, then the moment that you save your drawing, they will get a message. Hey, do you also want to synchronize this? And you can also always synchronize automatically. And then at the moment you save your drawing, it will automatically synchronize it. And if you have a drawing with just a few parts in it, then it's fine, since then it's quick. But if you have a very big drawing with a lot of parts in it, then it will take some time and it's maybe inconvenient. But that depends. So
okay.
I do verify synchronization. Maybe I should open the thing first. For this project, I do verify synchronization. Okay. Now I save my drawing. Let's make a new part. Here. Make a bounded panel. And if I now save this drawing, it should ask me, do you want to synchronize? It doesn't. So we try this again. Do options. Always synchronize. Is this now set? Yes. Is this the right project? Yeah, this is also the right project. Okay, good. Okay, let's try it again. It doesn't. Why? Maybe I miss another option here. What's this? Okay, well, I'm not 100% sure. Maybe I have to close my AutoCAD session and open it again. But anyway, so you can also do it automatically. So then when your drawing is saved, then it will automatically synchronize and then you don't have to think about it anymore.
Yeah, yeah.
But so that was a good question. You indeed have to sometimes synchronize your parts from time to time. And you can also do it like this. So here the synchronize project
yeah.
folder. And then you can say, I want to synchronize all the frames that I have with the database.
Yeah. This one is more, I mean, the fastest way to do the
whole project.
Yeah.
Yeah. Yeah.